Good morning all of you. Myself Jayeeta Majumder, Associate Professor of Department of Computer Science and Engineering, Haldia Institute of Technology. Today I will discuss with you on the topic of design of arithmetic and logic unit. Arithmetic and logic unit, that is commonly known as the ALU, which is the main important part of our system, where mainly all the arithmetical and the logical operation is performed, where data is coming from the input device via some memory location, and there the arithmetical and the logical operation is performed, and finally the output data goes to memory device, and finally from the memory to the output device or output world. The user can handle the data from the output device. So, what is the internal structure of this arithmetic and logic unit? So, before studying the arithmetic and logic unit thoroughly, first we required what is the adder circuit. So, because the arithmetic and logic unit, mainly arithmetic unit, totally based on the adder circuit. So, here in our computer system, adder is addition operation. So, subtraction is also performed. All of you know, that is the plus A minus B equals to A plus of minus B. Here minus B is mainly known as the 2's complement of the B value. So, that is why adder circuit is very much important in our life or in our system. So, first our system is the binary circuit based on the binary values. So, here the adder is known as the binary adder. So, a binary adder is a digital circuit that generates the arithmetic sum of two binary numbers of any length. So, what it is there? That is the arithmetical sum, that is the addition, subtraction, multiplication, division, all are the arithmetic operations. So, the digital circuit designed in this way, that is all the arithmetical operation is performed between two binary numbers. Suppose 1 1 added with 1 0 or 0 0, anything, any numbers of any length. It is 2 bit, 3 bit, 4 bit, any length. So, binary adder is classified into two parts. One is serial adder, one is parallel adder. So, serial adder, what is? A serial adder performs the addition of two binary numbers serially bit by bit starting with the LSB position. LSB means the least significant bit position. So, one bit position takes 1 clock cycles. 1 clock cycle means in a single unit of time period only 1 bit is added from the LSB position, and serially that means first the starting from the LSB position, then it moves to the previous bit of the LSB, then again the previous bit. In this way it goes on and finally ends with the MSB position addition. So, this is the circuit diagram of the serial adder. To design a serial adder in our system, one full adder circuit is required along with a flip-flop. So, what is the flip-flop? Here it is, that is it is set on the clock, that is a sequential circuit. So, that is why full adder takes the input, three inputs, the A and B are the two normal inputs, that is the bit value of the two binary values, and the third input for the full adder is coming from the output of the flip-flop. So, where the full adder take the input from the flip-flop. So, these three input generates after operation from the full adder, the sum is directly generated from the full adder, and the second output, that is the carry out, that is the Y value as per the diagram, it is again goes to the input taken as the input for the flip-flop, that is for the next bit. The carry is actually moves to the next bit. So, this carry goes to the flip-flop position, and again the for next bit is calculated. So, what is the advantages of this? The mainly very first advantages is the circuit is very small, only one full adder, one flip-flop is there, and inexpensive. It is obviously only two circuit is there, so it is less expensive. But disadvantage is it is the very slow, because it takes n number of clock cycle. If the bit value of the two numbers are n, so it takes n clock cycle for addition of 2n bits number. So the mainly that is the disadvantage, that is if the size of your binary numbers is increased, so the system is slow. To overcome this, the next adder is coming, that is the parallel adder. So to overcome the drawbacks or the disadvantages of the serial adder, the parallel adder is this, that is it adds all the bits of two numbers in only one clock cycle. So it has separate adder circuit for each bit. So one clock cycle for n numbers and separate the adder circuit for each bit. So every bit required one circuit to add. So to add n number of bits, so it required n separate adder circuit. So for each individual bit addition, that is the ith bit addition for two numbers ai plus bi, so again one adder circuit required. So ai plus 1, bi plus 1, again another adder circuit. So that's why this is the parallel adder concept. So parallel adder generally classified into two parts. One is carry propagate adder, carry look ahead adder. So why it classified? It is based on the carry generation from the parallel adder. So two types of adder circuit for parallel adder. One is carry propagate adder, commonly known as CPA, or sometimes it is called as ripple carry adder or RCA. And second one is the CLA, that is the carry look ahead adder. So the first diagram is the carry propagate adder. The next slide actually describes all the bit by bit addition. So from the first, I tell you from the diagram, if it is a 4-bit diagram called carry propagate adder. So if A0, B0, A1, B1, A2, B2 and A3, B3, that is a total two numbers A and B are each individually 4 bits, A0, A1, A2, A3 and B0, B1, B2, B3. So for individual A0, B0, that is the if I value is 0, so A0 and B0, it passes through a full adder, and the third input C0, initially the C0 is the carry in, it is initially set to 0, that is no carry at the very first bit position addition. So when C0, so C0 enter with A0 and B0, so it generate S0 corresponding sum bit, and the carry C1 is propagate to the next full adder, that is A1 and B1 added with C1 value, and it again generate the sum value S1. So from the second full adder, it generates the carry C2. C2 again propagate to third full adder, A2, B2 added with C2, and then S2 generate. Finally C3 propagate to FA, say fourth FA, that is full adder, added with A3 and B3, added generate the sum 3, and the C4 is the final carry out from the circuit. So 4-bit addition, it required 4 full adder, that is 4 individual adder circuit required for 4-bit numbers. So and it is name is carry propagate adder. Why it is named? That is the carry is propagate from the previous adder to the next adder. So in this way the carry is propagating. So this is the description of this, the sum output. A and B are the two values. 0 initially, the 0 bit is the lower order bit and higher bit is this number 3 bit, that is the A3 and B3, and carry is the C0 to C3, and C4 is the resultant output carry from the last full adder circuit. The sum output S0 and S3 require the arithmetic sum from the A and B. The n data bits, so A and B input different source of registers, it is required coming from the source register R1 A, and B is coming from the defined register R2. So arithmetic sum for the data inputs A and B transferred to the R1 or R2 in this anyway. Now most important, here delay is introduced. Why delay is introduced? Because it here the next full adder or the adder circuit is depends on the previous adder circuit output, carry output. So that's why because C1, when until or unless C1 is not generated, the second full adder is not start for its execution, because after C1 execution it taken as the third input to the full adder circuit. So that's why here delay is introduced. So if the maximum propagation delay for n bit value, binary values, it is del cross n, where del is the time delay. If we consider del is the minimum time delay for each full adder circuit and n is the number of bit for each operand, so del by n, del cross n, is the final delay calculation, propagation delay. The next, now to overcome this, again that is the how to minimize the propagation delay, we introduce carry look ahead adder. What is carry look ahead adder? A carry look ahead adder is a high speed adder. Why it is declared as the high speed adder? Where it is add two numbers without waiting for the carries from the previous stage. That is, here no waiting from the carry for the previous stage. So how it is possible? Here carry is generated actually with some mathematical calculation. What is it is known as actually the carry look ahead generator, who generate the individual carry for the next step based on the value coming from the each full adder. So the pink part in the diagram, the blue color is the full adder circuit, where it takes the data from the binary values and it generated original sum from that bit position, and another two P0 and G0, these two value actually is generated, and P0, G0 individually calculate the carry, and that carry is actually look ahead to the next full adder circuit. So in the full adder circuit, the carry output Ci1 is related to the Cy. That is, next bit carry is I plus 1th bit position carry is generated from the Ci, previous bit carry value. What is the formula? Ci plus 1 equals to Ai into Bi, that is the multiplication between dot operation actually, Ai and Bi, plus added with Ai plus Bi added with Ci, multiply with Ci. So Ai Bi plus Ai plus Bi into Ci. So the next bit is, so it is the, so Ai Bi, the in the from Ai dot Bi, actually it is known as the Gi value, and Ai plus Bi is the Pi value. So Gi means the carry generate, Pi means carry propagate. So this, the sum of this sum and carry, when we calculate the sum and carry for the CLA, so Si sum equals to Pi XOR operation with Ci, ith bit position Pi, and Ci plus 1, that is a carry of the next bit position, is calculated from the carry generate Gi plus Pi into Ci. Okay, so here some description about how to generate the carry. So suppose Ci equals to if I value is 0, so carry is coming from, for calculator for the 0 plus 1, I plus 1 means 0 plus 1, that is C 1th position. So C 1th position carry is calculated from G0 from the formula, that is the formula Ci plus 1 equals to Gi plus Pi dot Ci equals to C1 equals to G0 plus P0 into C0. That means the next bit carry, C1th position carry, is depending on the ith position values, that is G0 position value and the P0 and C0 value. Similar way, C2 is depending on G1 plus P1 dot C1, C3 G2 P2 dot C2, and C4 G3 plus P3 dot C3. So in this way, if we substituting the C1 to C2, that is C2 is G1 plus G0 into P1 plus C0 dot P0 P1. In this way, if we calculate C4, so we check it is totally based on the 0th position value, that is C0 only based on the C0, which is the initial carry or the initial carry input in the system. So here we minimize the time delay. So the maximum delay, if we consider or calculate for the carry look ahead adder, it is calculated as 6 into del. Del is the time delay, the value or minimum amount of time multiplied with 6, which is less than compared to the carry propagate adder. So this is the two concept of the carry look ahead adder and the carry propagate adder. So it is the description of this. Now important is, next point is the binary incremental unit. So why we study it? Because our arithmetic unit all are based on the incremental operation, decrement operation, addition, subtraction operation. So that's why it is the incremental unit, binary incremental unit. So it is the diagram, half adder circuit is required here. So in the increment micro operation adds two binary values. So suppose here I consider again 4-bit register values, or the 4-bit binary values. Suppose 0, 1, 1, 0. So if it is passes through the incremental circuit, it returns just added with 1. So it returns 0, 1, 1, 1. So how it calculate? So the increment operation is best implemented by a 4-bit combinational incremental circuit. So it is, this is the block diagram. So you check in the first half adder, if we consider A0, A1, A2, A3 are the bit values of the original value. It is the needed for the incrementation. So 0, 1, 1, 0. So A0 value is 0, A1 is 1, A2 is 1 and A3 is also 1. So it is added with 1. So for one logical 1 is passes as the second input to the half adder. So after addition, one sum is generated S0 and the carry is propagated to the next half adder, which is treated as the second input to the next second half adder. So in this way S0, S1, S2, S3 and the from the last half adder it is generated the C4. So if it is, so in this way C4 will be 1 only after incrementing the binary 1, 1, 1, 1. So in this way the carry is generated, binary incremented. Now binary decremental unit. So binary decrement operation is not, again decrement means A minus 1. If A is the binary bit value, that is suppose A equals to 1001. So 1001 equals to minus 1. So A minus 1 operation is performed here. So now here is the twist. So minus 1, how we calculate minus 1? Using the adder circuit. Okay, here also the adder circuit is used. So how it is treated? So 1 decrement means, what is the value of minus 1 means what? Decrement means minus 1. So minus 1 for a 4-bit circuit, it is the binary value is 1, 1, 1, 1. So if we convert minus 1 into its equivalent binary, it is returns 1, 1, 1, 1. So minus 1 means the 1, 0, 0, 0, 1. So if it is 2's complement, it returns 1, 1, 1, 1. So this 4, 1 actually passes through to the circuit. So A0, A1, A2, A3 your original value. Now the plus 1, 1, 1, 1, the second input, that is the binary minus 1. This added, so first value is half adder. So half adder takes, because no carry input from the initial stage. So first one half adder is there. So the normal S0 is output generate. The carry generate to the and passes to the next. So say from the next it is required full adder. So 3 input A1, another one along with C1. So generate S1, then SC2. In this way final carry is generated and normal S0, S1, S2, S3 is created or generated from the circuit, the normal summation output. Now the next one is the binary adder subtractor unit. The binary adder subtractor unit, that is the both operation, adder addition operation as well as the subtraction operation is performed in a single circuit. So here two operation, here also we take 4-bit adder subtractor unit. So here along with full adder some XOR gate also required, because for the operation. So if circuit is on, it is treated as the adder circuit. If circuit is XOR output is 0 or 1, it is treated as the subtraction unit. So how we calculate? So here the mode input M is the logic. Mode input means this input. So if it is 0, 0 means that value 0 XOR input along with the B0 input. So B0 input is passes through the XOR gate. So XOR gate output gives the final input to the full adder circuit. So here the exclusive XOR gate is the series received from the input M with the one of the input B. So if M value is 0, the B value with the XOR operation 0 returns B. So normal B value is passes, so it is added. And if M value is high, that means 1, so B XOR 1 means B complement, that means it is treated as 1. So similarly all 4 1 B complement means minus B, so then it is treated as the subtractor unit. So when that means based on the M value, that is the control circuit input value, if it is 0, then it is treated as the addition operation or adder circuit. If it is 1, then it is the B naught, that is the minus, so that is the operation is subtraction unit. So here actually we study adder, all the adders, that is the binary adder, parallel adder, incremental unit, decremental unit, as well as the adder subtractor unit. Now the most important, it is the arithmetic. What is our desired topic? So arithmetic unit based on all these operations. So the basic arithmetic micro operation in this circuit, here we design suppose 4-bit arithmetic unit. From the diagram you understand, here 4 marks is there, 4 full adder is there, along with 4-bit input, that is the A0, A1, A2, A3 and B0, B1, B2, B3. Now how it execute? Actually the circuit is calculated based on this formula, that is D equals to A plus YC in. So where A is the normal input of 4-bit numbers, Y is the output from the multiplexer, and C is the carry input bit to the parallel adder, that is the C in. So based on these 3 inputs, actually the final output is calculated, that is the D value. Okay, so now this is the function table based on the circuit. So how it is? You check. So here actually from the diagram, 3 for the marks, so 2 serial line is there, 2 selection line, S0 and S1 and C in. These 3 actually the inputs. So 3 inputs, total 8 operations, so 8 combinations, 0 0 0 to 1 1 1. Now Y. What is Y? Y is the input, that is the Y value. What is the how to calculate the Y value? Y value is nothing but the B value. So you check B value is direct B value or the complemented B value, along with some 0 value and logical 1 value. So B complement 0 and logical 1. So based on this input, so D value is directly calculated A plus Y plus C in. So initially for the first cases, D equals to A means the A bit position value, added with plus direct B value, Y value is B. So Y value actually the output of the marks. In this, here you check, Y value is the 4-bit output of the multiplexer. So multiplexer is 4 input. So what is the input of the multiplexer? That is the S0, B0, B complement, along with 0 and 1. These 4, among these 4, only one output input is selected. So from the first one, suppose B0, from the second based on the S0, S1 value. So that's why S0 and S1, when 0 0, the first input is B0, so that B means directly B value. So A plus B, second option is A plus B, C in means that is the 1. So A plus B 1, it is the, what is the operation? Addition with some carry. Now when the selection line is 0 1, Here also the two types of input 0 and 1, and the input marks input is the second line, that is the b complement. So a plus b complement, and second one is a plus b complement plus 1. So subtract with borrow, and second one is only normal sub. B complement plus 1 means minus b. So that is the normal subtract. Now third input is selection line is 1 0. So when 1 0 means logical 1 input. So d equals to a, nose carry, and d equals to a plus 1. That is the transfer of a, that is the a value directly goes to the output, and a plus 1, that is the increment operation. And last of combination is 1 1 1 1 with 0 and 1. So d equals to a minus 1, that is the decrement operation. So and finally d equals to a, that is the again the transfer operation. So this is the function table for this 4-bit arithmetic unit. So this is the diagram, this is the logical operation, and finally the logical unit. So the logical micro operation is the special type of binary operations based on the bit position, actually bit by bit position. Here 4-bit. So first we check the diagram. So it is the diagram for the logical operation. So 4 into 1 mux is there. So to activate the mux, selection line is required, S0 and S1. Now AI and BI, the two ith bit position value. So here we take only 4 micro logical operation, and is AND, OR, XOR, and the NOT. So based on the selection input, suppose 0 0. So the 0 AND gate is connected with 0 position value marks. So A and B operation. So operation is AND. 0 1 A or B, that is the OR operation. 1 0, that is the A XOR B, XOR B, that is the XOR operation. And finally 1 1, it is collected. 1 1 is connected with the only the A bit value. So that is in the fourth input. So that is the A complement. So in this logical circuit only 4 operation is performed, AND, OR, XOR, and NOT. If you connected an AND, NOR, anything, it is connected with this marks. So here arithmetical and logical, both the operation is we check how it is calculated or it is function. So in this video I give you the brief overview of the carry different types of adder circuit, carry look ahead adder, carry propagate adder, all the circuit unit, addition circuit unit, subtraction unit, along with the mainly arithmetic unit and the logic unit. So hope you and all of you understand. In the next slide I will try to design how to design the total final arithmetic and logic unit combinedly. So thank you for today. Hope you understand. Thank you.